Hey, you mean intro mai?
可夫，可夫，能听见吗？
Hi. Yeah, 可以.
哎
But
呀
the recording is the meeting is recorded, so we'd better have the meeting in
，OK
English instead of in Chinese.
OK。So
Here's anyone.
did you read those the comments about the memory store? He
Yeah, I
suggested we.
briefly skimmed over it, but I didn't get a chance to read it closely.
Okay, so
Alex,
oh, hello.
Morning, Red Oak. Afternoon, Yixing.
hello.
Where is Jianpeng?
Yeah,
Let me find him. Oh,
thank you.
he's joining.
Afternoon, Jianpeng.
Hello, 可夫。
So we have a full quorum here. Okay, let's start from me. Last week I was working on putting up Chrome's OSD, and it turns out there's some, but more importantly, we have a discussion regarding to the proposal by Redux on single-threaded Chrome's OSD. Probably that's what we will be discussing in the following part of this stand-up. And when I'm working on putting up Chrome, I found that we need to adapt to the V2 changes in short term or in mid term, because the OSD map has been changed to use the V2 interfaces. To be specific, let me post a part of it down. For example, when the OSD put up, it will check if it is up marked by OSD map, and if its address matches with the ones noted in the OSD map. It does not, it will try to reboot itself. But before the V2 transition, the addresses of a certain entity is the singular, which means that there's only a single address in the represented by an entity. But after the V2 transition, each OSD can bound to multiple addresses. So probably I will, or anything you could help on this adaptation. And I think once the once we put up the OSD, get the OSD so it can be discovered by monitor and its peer, we should be able to start working on the MS handle OSDOP or MS handle replica OP, etc. The handle methods exposed by the dispatcher. And that's me.
So sorry, I don't understand the difference between the current V2 with the original one.
Okay.
Can you repeat?
I think that's what I found is a tip of iceberg. The thing I found is that in V2, each entity can be bounded to multiple addresses. So
Okay.
in the take OT for example. If you get an address in V1, if you get address by its ID, only a single address will be returned. And after V2 transition, a new type of address representing multiple addresses is introduced, like entity address vec_t, in which vec is a vector. So a vector of addresses will be returned instead of a single one.
So you mean each OSD can be set multiple IP address?
True.
Okay. So why we add this multiple IP address here?
I'm not quite sure, but I can send you a certain mail regarding to the background of the V2 transition and why we want to introduce this feature.
Okay, thank you.
I don't think it's a little bit off topic regarding to this the problem we're facing, but important. I know.
So it's only influenced the OSD map cache?
No. No, I don't
The
think so.
messenger.
But this is the one I'm facing.
Okay.
That's all I have, and I will try to get it done before the end of this week. And that's me. Regarding to the review, I didn't make much progress regarding to reviews. I will try to do so for on the at least for the messenger reviews.
Okay.
Chumei, how's the holiday?
Okay.
And what's up?
Travel for 3 days to the Yosemite and stay at home for several days for the New Year. And then I'm back on last Wednesday. And I'm working on some comments from Riddles to make a little change on the memory store test case. And then Riddles suggested we add encapsulation for the object store. So I'm considering that and working on it. So I'm going to show what the encapsulation looks like. I paste here. So I'm going to define futurized object store. That object store will define some virtual API, the similar as the object store, but the return is the Seastar future. So the input is the same. I keep the same as the object store. the input parameters are the same, and the output type is the same, but return the Seastar feature. So for the every object store defined API, I will implement the encapsulation with the same input and output, but the return is the Seastar feature. And
So
then
it's basically an adapter for the existing object store.
this one is not adapter, it's just define the same interface as the object store, but the return is the Seastar feature. And the adapter looks like this one. I didn't call it adapter, I call it align object
Line.
object store, and it will implement the Seastar feature interface, and this looks like this one. So for example, it's not easy to see, something like that.
I see.
In this function, we will call the in this align object store, we'll define the thread pool and object store. This one, in the align object store, we'll define the store and the thread pool. It will be initialized when called the construction function constructor. And for the read, for the object store API read, we implemented by the thread pool. Use this pointer to get the thread pool, and use the submit to the POSIX thread to execute. So it's just a wrapper, only use the thread pool to execute the store's read function. I'm trying to implement it like this. So first, define the virtualized object store. In this futurized object store. In this class, only define the virtual function. The same for the API has the same input parameter and output parameter, but its return type is Seastar feature. And then in the align object store, inherited the futurized object store and implemented these APIs. And the aligned object store has the store. You can create it to be the memory store or other stores here, and has the thread pool in the aligned object store. So the aligned object store API, for example, read, they just get the input from the outside, from the OSD, and when the OSD call the store read, they will call here, and in this read function, we'll get this pointer. So we can get the store and the.
Sorry to interrupt you. Are you sharing your screen, or I cannot?
I just how to share my. Oh, okay. Share.
Okay. Anyway, it's.
Share my screen. Okay. No problem.
I can hardly follow you if you are mentioning this function or that function.
Oh, because I just use the chat to paste the function, but we can see my screen.
Okay.
Can you see my screen? Can you see my screen?
Okay.
Can you see? Pardon? Use. Oh.
I cannot see your
No,
screen, but
okay.
that's fine, I guess.
Can you see?
Yes.
Yes. Okay. Okay. Can you see the screen?
Yep.
Much better.
Okay. So here, I define a futurized object store. So this object store just define the same virtual API as the object store. The object store define the many virtual API. So here just define the same. I give the example, the read and some queue transaction, not all currently. So create a new collection, something like that. And this API has the same input parameters and output parameters. If it's if object store return int, here return Seastar future int. Okay, so the same input input parameter and
why would we need to introduce the alien object store? We already have a featureized object which is
object store is implemented all the any object store implement all the virtual APIs, and it has its own store instance and thread pool instance.
Okay, so featureized object store is used as
that's
the
virtual
interface.
API. Yes, it's the interface, and any
just like object store for existing OSD.
Yeah, okay, inherited the virtualized object store and implemented all the APIs. So here, but it has its own store instance here and the thread pool instance here. And then,
put it another way, the alien object store is an adapter for the underlying object store.
Yeah, so here the store can be created a memory store or blue store or other store. It doesn't matter because from this alien object store, we'll call the store instance API. The API just, for example, the read. So just do a wrapper to get the thread pool and submit the parameter to the POSIX thread and to execute the store instance read. So I keep the same input and output. So the OS code just like the original code called the store is okay. Understand?
Two quick notes, if I may.
Sorry, Riddle, there's so loudly from you voice is hardly to recognize your voice.
Echo in
Also, let me switch.
Hello?
Is it better?
a little bit better, yes.
But I still can't recognize what you said.
I just think we'll be back in a second.
Thank you. It's better, but I can hardly hear you.
So do you understand my what I'm thinking here? Just add a wrapper, the same input and output, and this wrapper API will use the thread pool to transmit the execute in the POSIX thread.
I hope now is better.
Much better.
So first of all, I think that Chunmin just started from defining a new clean interface called Futurized Object Store. It doesn't inherit from the current object store implementation at all.
Yeah, it's not inherent from the.
Yes, I'm not sure that basically I think we will get in the first phase at least two implementations of it. One will be the adapter for currently existing object stores, but the second, and I guess even more important one, will be just futurized mem store implementation. Just for testing and just for very quick development.
So we needed to implement the memory, futurized memory store, because here just call the store instance can be the memory instance, memory store instance.
Of course, but it has some drawbacks. First of all, is that you need to go through the you need to cross the core boundary. It means it will affect the performance. Second thing, I am afraid it's just not it won't be enough to just wrap the calls from currently existing object store. I am afraid we would also need to take care about ensuring, about making safety for the parameters of the calls to cross our boundary. I mean, especially the buffer list parameters we both take and return from currently existing store. I expect it will be hard, to be honest. But I don't think we need to worry about that right now. Personally, I perceive the Crimson OSD as a prototyping project just to verify our assumptions we made in the matter of Seastar. So maybe we don't need to worry about serving any object store implementation we have right now. Of course, in the later perspective, that I think it will be needed. But just from the testing perspective, a memstore instance could be enough. And from the testing perspective, it will be even better to have the memstore instance living in the Seastar world. I mean, living on the same reactor, on the same Seastar engine, all together with rest of the OSD. And I guess we can easily accomplish that. First of all, yeah.
So you mean the memory store not running in the POSIX thread, just running in the Seastar thread?
Exactly. That's the idea.
Yeah, but that is not what we discussed result.
Sorry,
so
could you...
because before the first step, first time we think to run the memory store in each Seastar thread, but last time Kefu and I and Greg discussed it, and we don't want to change the object store, so we want to put it into the.
We won't change the memstore we currently have. Just please take a look on the comments I linked in the chat. The idea.
So you mean each Seastar thread has a memory store. Each Seastar thread has a memory store, right?
Right.
The memory store is sharded.
Well, it's not aware about sharding. Not aware about sharding. If your Crimson OSD would use sharding, well, Christ object store would live in multiple instances, I guess. Don't think
multiple memory store instance, right? You mean?
I think there will be only one. It depends on how many Seastar reactors, how many Seastar engines we want to put inside single Crimson OSD. If there will be multiple reactors, I guess there will be the same number of futurized memstore instances. But I also think that we might end with just single engine per Crimson OSD process. If so, it will be the same. The same would apply to futurized memstore instance. And futurized memstore basically means that it will be separated from the memstore we have right now. That's the reason why I propose to privately inherit from a currently existing memstore, and just to expose the really necessary things using C++ directive, plus implement all the new methods we have in the future-based object store interface. Of course, I'm aware that memstore has some locks internally. It has even more complex things in type of read-write lock. But I also would love to point out that most likely we'll be able to kill it. Just move. Personally, I perceive the Seastar as a very dumb, very primitive scheduler with voluntary preemption, like in the 80s. Very nice thing, by the way. This means that if you don't declare any preemption point, you won't be preempted. And I think that the preemption points in Seastar are mostly because IO. If your code is not doing any IO, nor it doesn't use the continuations concept, basically it's free of preemption. It means that also put all together with the idea of having just one thread visiting operating on the same data, it means you can have some kind of wrapper for the read-write lock. Maybe def read-write lock. Anyway, anything. The idea is to have if-def, basically nullifying it for the Crimson builds. With atomics.
The first I'm
Yes?
thinking each Seastar thread has a memory store instance, and then they used a different file to save the data, so we can remove all the logs.
Well, I expect there will be only one thread in Crimson OSD.
Pardon?
Careful, you're muted.
Oh, sorry. So, Redoc, you mean actually you are talking about one-to-one mapping, Crimson OSD, where there's
Exactly.
only single object store for each OSD instance.
Exactly. Served by one, ideally served by one thread. One reactor inside one POSIX thread.
Yeah, one core, one reactor, and a single object store.
Exactly.
In this context, it's a memory store. So ideally there's no racing or no competition between different reactors for grabbing the object store. So there's no waiting for the core or for the object store.
True. It can be that we could consume memstore even without nullifying the logs inside, without nullifying atomics it currently has. Well, atomics would still be memory barriers, but maybe we can live with them. If not, we can go even further and kill them with atomic wrapper or something like that. The same with the same idea with read-write logs. The same idea with mutexes.
I think why Redoc wanted to emphasize that a memory store is simpler for our current problem. Currently, we want to test test and to prototype the Chromosome OT to find how it performs and have a minimal implementations and the fast pass. And the discussion we have to have a wrapper and to have a wrapper around the existing, for example, the Blue Store. That's the final goal. We are trying to approach at the end stage of Chromosome OSD, because we put a lot of efforts on we are putting a lot of efforts on the optimization and the performance of Blue Store. But at the current stage, we are trying to get a prototype of a Chrome Store. That's, I think, and the memory store is very fast, and from Seastar point of view, it's non-blocking. So the CPU store detector in Seastar won't notice that it's performing I/O. Actually, it's the major I/O is performed in memory, so it's not a big deal. So I think in long term, we need to have a object store living in the alien world. But in the following 1 month or two, probably if we focus on the featureized memory store, that will be easier for us.
Yeah. So the code needn't change, right? We just
I really think we can reuse your code in future.
Pardon?
I think the design and the code can be reused in future once we switch over to Blue Store. But at the current status,
yeah, I mean for memory store, if you use the memory store, so maybe you needn't change the code, just call the interface as okay.
No, because in existing your existing design, we have a ping pong between the two worlds and probably two core. You know, for the alien worlds are backed by a different cores. The alien threads are living on different cores. The memory chunk and the task is posed to different cores, and it's task queue. So it incurs some performance degradation, which is not expected at the current status, because we wanted to see what's the best performance we can achieve using Seastar.
So you are talking about the single thread OSD?
Not really. It's more about what the best performance we can have without all the overheads between introduced by the alien object store. If we keep the memory store in the Seastar world, we can eliminate all the overheads. I know we cannot ignore them in future, but at the current status, we can. And it
you just want to
the design.
You want to run the memory store in Seastar thread, right?
I think that's what the readers want to. As it's simpler and it implies better performance. I recall that Jianpeng and you are urging us to have the profiling number ASAP. I think that's what we are focusing on. Yes, the quickly prototyping is the most important thing.
Go on.
Let me summarize. the idea is we need to prove assumptions. We are assuming that putting Seastar into the game will bring significant performance benefits. But we are not sure. We need to prove it, and the simpler, the cheaper, the quicker we will do that, the better. So the idea is to quickly prove our assumptions or just fail as early as possible. I believe the worst thing we can do is to burn a lot of time, tons of our currently existing code, just to say after maybe a year from now that, well, guys, sorry, we thought that Seastar is super cool, but it isn't. But if we say that after 2 months of development, I don't think it's a big problem.
So for the
Well,
simple POC, so we can set the single thread OSD, right? It's simple.
Yes, I think so.
Yes, that's the fastest one. Fastest
Yeah.
approach.
So if we want
prototyping.
to quickly get the performance test result, we can just implement the single thread OSD, and then we just run the original self, set the thread is 1, and to test to compare the result if you want to. So we needn't solve the data structure sharing problem, and we needn't care about the logs.
That's also my impression.
Yep.
So let's very quickly to compare the performance result. But for your side, you don't want to use the code not used later.
Yes, we need to aware
But
that which part we probably it's not performant, but we need to be aware about where the performance could be hurted. But per the discussion over the mailing list, the M2M mapping mode did not buy us a lot, and the memory overhead introduced by non-shared OSD map is not it can be ignored. So I think the one-to-one mapping, the benchmark of a one-to-one mapping model, could present the what we will have using Seastar. And the code is simpler, and so even if we found that we need to switch over to M2N, we don't waste a lot of effort devoting to one-to-one mapping.
I'm currently working on abstracting the differences between sharded and not sharded Crimson OSD. I just I started from abstracting the way how we create Messenger, then moved to the way how we create monitor client, then also make some simplifications on how monitor client consume Messenger. Before it was just association. After it's stronger aggregation. The idea is to have a dedicated messenger for monitor client that could take it exclusively.
Yeah, and if we go with the one-to-one mapping, we also need to have a different set of configuration values for each config proxy instead of a shared config value.
For one-to-one mapping, do we need the configure proxy? It's just one thread for one OSD instance, right?
Yes. But currently,
So,
for example, the config proxy shares a single instance of a config value. So if we want to go with 111, it will be perfectly sharded and share nothing a config proxy.
so what do you
I
mean the
want to
111? 111 means the one OSD instance has one Seastar thread and has one device.
yes, that's a
So
one-to-one
so
mapping
no
model.
so there is no shared data structure. Only one thread. The one thread do all the things.
I think so. One,
So
it's more
no shared
to
data.
put it in a way, and it's a single reactor to all the job.
Yes, so no shared config value.
No,
It's just
everything
one
is
thread.
perfectly sharded and share nothing.
What do you mean sharded? Sharded means multiple thread.
By sharded, I mean in Seastar we have a sharded service, but config proxy or perf counter are sharded service. Currently, there are some data structure shared by each instance of a sharded service. But in a
for our
one-to-one
one-to-one
mapping,
map, no sharded service, just one shard.
we can put it we can see it from different way. If a service is sharded, it could choose to share something or share nothing. In one-to-one mapping, a shared service does not share anything. What it shares is the data type of the sharded service. That's all. That's
Okay,
different
so you
from
just
what
want
we
to keep
have
the
now.
currently, want to keep the currently we have done, and just
No,
run it in one shard.
no, that's not what I'm trying to have. I'm just to explain that if we want to go with one-to-one mapping, we need to remove the shared data structure from, for example, the perf counter or more importantly, config proxy. So it won't share anything between the instance of the config proxy.
So if we just run the current code, the test case in one call, what happened from the configure proxy code? I think it can be run in one call, right? I mean, if it can run in on one call, just one call, so we needn't change the code.
That's true.
Or we can
true.
get rid of all the, or give up all the code and just not use the configure proxy, just use the originally figure data structure is okay.
So that also implies another question: how we will benchmark the current OSD and the existing OSD? Will we run them one side by side and only single threaded?
Yeah, it's simple, right? It's simple test case and easily faster to implement in our current.
Is there any way we can run existing OSD using a single core?
Yeah, we can set the shard number to be 1 and the number of thread to be 1.
Exactly. The same with messenger threads, but maybe the different idea is there. Maybe we could just give the same node with absolutely the same parameters. We could maybe give two nodes with the same parameters, the same configuration. One for current OSD running memstore, one for Crimson OSD running futurized memstore, and just try get as much IOPS as possible. I'm assuming we have also infinite numbers of client hardware nodes.
So in current configure file, you can set the async messenger working thread. You can set the OSD working thread, OSD shard number per thread.
But
Per thread
but these threads are
per shard.
scheduled could be scheduled to different core by the kernel.
If it is one thread, yes, it will be scheduled to different cores.
So it's not an apple-to-apple comparison.
But that is why we are better than the existing OSD, right? We have no thread switch. That is why we use the premise.
Bingo.
I see, but what I'm concerned is that it's if in the competition between the Seastar OSD and if the Seastar OSD fails the competition with the OSD, we cannot just put that it does not perform well because the existing OSD have more cores. Can utilize more cores than
I see.
Than Crimson OSD. It's not fair.
Well,
yes, I see.
That's the
not fair game.
That's the idea. It hasn't been said we cannot deploy more Crimson OSD's instances than that the number of instances of currently existing on the OSD. I mean, the only limitation should be the resources available in testing nodes. Yes?
If the server has 82 cores, we can create 82 OSD instances for both existing OSD and Crimson.
Well, I guess the number of instances. I guess that the number of instances doesn't really need to be equal between current Ceph or -OSD and the Crimson -OSD. It can be different.
But we have to how we compare the performance.
So we'll just take a look on the IOPS we are getting from the same machine.
Yeah, but if we just run one OSD instance, because the Ceph OSD can be scheduled the thread to the other cores. So at the same time, maybe multiple cores working parallel. But for the Crimson, only one core work.
If there's there's 4 disks or 4 object stores co-located on the same host, we can start 4 instances of or 4 different Crimson OSD and ping them to 4 different cores and get the benchmark result. And then on the very same host with the same 4 object store, we can launch 4 existing OSD for the benchmark. So that result would be fair.
Yeah, create the same number as the cores, same OSD instance as the cores. Right?
Yes.
So that will be fair. We used all the cores. We used all the cores.
Not necessarily all the cores because I believe there will be more cores than the number of cores will outnumber the disks. But I think that would be better. But would it be ideal if we can shut down some of the cores on when we are testing existing OSD?
Okay.
Sorry, guys. Sorry, folks. I've got lost. We are talking about testing Crimson OSD with Memstar instances, right?
Yes. We want to compare the Ceph OSD and with the Crimson OSD.
I thought
how to compare it?
Sure. I thought for Memstar there is basically no any device underneath. object store. Mem store is an extension of object store
Okay, that's
that
true.
resides on memory. So basically, our computation, our resources are just CPU power and available memory. Let's say we will got nodes with almost indefinite number of memory modules.
Yes.
Okay,
Yes.
so if we have a 64 cores, we can have a 64 object store backend. That will
Exactly.
be for one.
Yes.
Okay, that will be fair game, a perfect fair game for even
So
for
currently, can we get the conclusion? We just do the single OSD thread POC and one call run to complete finish all the work just in one call.
yeah.
Then
And
that
we
would be
can
simple
reuse
to
the existing
compare
config
the
proxy.
if I think that code can be running on when you give the Seastar call to be one, I think that test code can be run. So maybe no
Yes.
problem.
Yes, agreed.
Okay, so how to start work?
I think the action item is that the first thing we need to get the object, the OSD boot up, and so we can work with each other and talk with each other and be discovered by the monitor and be able to talk to its client. That's why I think one of the foremost important tasks is to get it boot up. That's what I'm working on. And the second thing is since we are working on the master branch, we need to address the interoperability between the current monitor and the monitor on master branch and probably manager. So we need to address the V2 interoperability. And also please go on.
So how to divide the jobs from us to working on the OSD boot up? It's a serious API call, right?
I think it's not that it's pretty much it's important, but it's trivial. I can get it. Hopefully I can get it done by the end of this week.
Oh, so if just for the one OSD one Seastar thread, then it's easily to boot up the OSD, right?
I don't think it's different from multiple OSD. Anyway, I think that's the first thing, and another thing is to get the featureized memory store, and to
you
get
still
it connect to
continue working on the futurized object store, right? I still need to continue on the work, right?
I think if we want to get the number ASAP, we need to focus on the futurized memory store and only futurized memory store, so we can get the minimal prototyping OSD.
What do you
ready.
mean the futurized memory store? So you because it is no block in the memory store, the read write no block, you just can only for the mount save some operation, I think will be block, but the other read write no block.
It's a matter of interface.
Yeah, it's
Yes,
memory
that's a matter of
interface.
Probably you can just use the non-blocking interface at the current stage. What do you think, Riddles?
Yes, that's the idea.
We needed
That's
to.
a little bit. I thought it's a little bit cheating, but That's what we are doing now.
Well, we will if the locks are really a problem, it will show in our performance testing. If so, we have a ready approach to address them. But I don't think we need to be worried about. We don't need to fix a problem before it appears.
Yes.
Yeah. So once OSD is read,
It's
once
certainly a
Seastar is
quick
read,
approach we have.
no locks in the memory store, no block. So we needed to
No lock.
modify. We needed to modify the code because the lock is not multiple thread. So the lock you can remove the lock and the read write memory no block.
I see you what you do. What do you mean? Technically, well, if we discover the locking inside memstore is truly an
we can
issue,
solve it.
we could just abstract. We could just prepare a type abstracting some types like read write lock, like atomic STD atomic, like all that stuff, and say in the wrapper that for the Crimson, for the Seastar build, the mapping is just nullification. Of course, we would need to apply, we would need to change the memstore itself just to use this new wrapper. But it would be one-liner basically. You would change STD atomic, Tef atomic. I guess it's pretty mergeable and nobody will say no. The most important thing is to just keep the implementation of extra methods coming from the futurized memstore interface, like the returning Seastar future. The primary goal is to keep it from the current memstore implementation.
Yeah, and also we need to make sure that the memory store does not have a lot of dependency on the alien world. If yes, we need to fix them at the compile time.
We don't use the POSIX thread, not alien world. Just the one.
Yes, that's why I think we need to.
And no alien communication.
True, but
Sure.
I guess keep in mind the dependence just on other components of CEF, like buffer. And by the way, CEF atomics would play nicely also with Seastar, with buffer list, with the atomical reference counting we have in buffer row. We could switch to CEF atomic.
I just wanted to make sure that the memory store plays well in the Seastar world instead of assuming that it is a multiple-threaded application. For example, we need to ensure that memory store won't start some thread, POSIX thread to work from it. It's a cheat otherwise. And
Sorry,
it's a
don't understand you.
We need to audit memory store to make sure it does not use some POSIX thread, for example.
Good point.
We mean not use the POSIX thread.
If I recall correctly, memory store using some finisher.
Yeah, we have to modify it because for us it's ready to complete. We have to modify it. No finisher thread.
Sure, but finisher threads are, I guess, that are mostly because of the queue transaction, are mostly because of modifications. Right now we are going with just reads.
Okay, then that's fine. You assume that we only will focus on the read path. That'll be fine.
For
exactly.
any queue, we have to modify the enqueue and dequeue because we needn't enqueue and dequeue, right? It's run to complete just for one thread.
Yes. For read for serving read request, we don't need to do a queue. Okay. Okay then.
So we have to go through the IO. Oh. So if the one Seastar thread and okay, and we'll go through the path, all the paths
I
to
think
make the
Redux
tasks.
has a. I think probably we can walk through the updates from our team member and go back to the action items and split them. How about that?
Perfect.
Yeah. So Zhenpeng, how's it going? I thought you are working with Yixing to benchmark the course core messenger.
Yeah, last week I saw the first performance result, but meet memory leak in Seastar message. Last week I fixed it and retest and I will show the performance. Can you see the screen?
Yes.
After fix the memory link, from the result, I think message still better than the Seastar message.
Mm-hmm.
Oh, you have get
Only
the
for
result.
yeah. Only the result of the QD 32. We improve Seastar message improve much, but for other QD test the performance don't change much. But from the whose result, I think message is better than the Seastar message because
Bad news.
yeah because other things I don't do performance profile suggested by the Redux law. So the next step I will use the prof and the work log do the performance profile and show the result.
How many threads for working messenger threads there was for the file 8 scenario?
So how many I think work thread you configured?
One thread because only one client, so there is one connection. So for the single thread, there is only one thread to.
Only one work thread start up.
Yeah, although a single message have three worker, but because there is only one client, so there is only one thread to work.
Working. Oh, okay.
Yeah.
So Seastar is one thread.
So this is the apple to apple compare.
Okay.
So Seastar is one thread, right?
Yeah. The same client with the same configure, and for the server there is only one. I think sync work, and for Seastar there is only one call.
Messenger. Oh, wasn't only one. Okay.
So have you checked the CPU usage?
I don't check this. No, I
Okay,
think
so
maybe
mhm.
maybe the first we must for the we must see the performance, not the CPU
Use it.
utility.
Yes,
I
we
mean,
have to.
Yeah.
I mean, if we get if this is bounded by CPU or by the NIC throughput, the network interface card throughput,
What's me?
why? I mean, we need to understand why we cannot get a better number with the Seastar or with async. If they are bounded by the CPU or bounded
Yeah,
by
They are
we
the
need.
still doing the investigation.
network card throughput.
I guess I guess that the wall clock profiles could be useful. Not even CPU cycles profiles from perf, just wall clock via Mark's GDB PMP, or maybe better, Adam Kupczyk's wall clock profiler.
Okay,
Yeah, we need some wall clock
I'll do
profiler.
this. are you mean for a sync work is not a pin on fixed core?
No, I I have no I'm not making any judgment here. I just want to understand where the bottleneck is.
Bottleneck, I think, because I using 10 gigabyte NRC, so I think the network is under the bot is not the bottleneck. I'm using the top C, the one CPU, 100%, but I didn't collect CPU use.
So for both
So
System Messenger and ASIC Messenger, the CPU is bounded, right? Or put in other ways, saturated.
bounding, what mean bounding?
I mean the CPU usage is 100%. CPU bound task. I mean.
Yeah.
Anyway, we can have a wall clock benchmark to understand where the bottleneck is. But the gist is that the Seastar messenger outperforms the async messenger. Is that right?
Yeah.
Okay, cool.
That's all.
Thank you, Jim.
Thank you,
And
Jim.
the Redux, how's
We
it going?
hope we can have a better promise result.
I'm working on abstracting the differences between sharded and not sharded environments inside Crimson OSD. I have a WordPress branch. I've got a question basically. It's about this particular commit. I will just to ensure that we don't want to share single manager instance between multiple clients, especially between monitor clients. I made them. I made one-to-one binding between them. Between the monitor and the messenger it uses.
Mm.
Do you mean the monitor has its own messenger?
Sorry, I haven't got you.
Do you mean each monitor client will have its own messenger?
Exactly.
What's the consideration about it? Why it is needed to have standalone
Well,
messenger?
it's just easier to not share a resource than share it. It's basically it's only a simplification.
Okay, simplification.
I think it's the easiest way to get it done. To share nothing at all.
Well, guys, I think that we will need. I would prefer to not spend our complexity budget on the very beginning of the project.
Agree.
From the experience, I see the things are evolving and the complexity is growing. So if we would start from something that is already very complex at the very beginning, the complexity will never drop in the future. It will be even more complex.
Yeah. We can clients. Yes. Currently, we can have the client own its own messenger and have each OSD instance has its own client. But I need to point out that a client messenger, if we will have a full-blown Crimson OSD, each OSD will be reporting to the manager, and the client messenger will be responsible to the traffic to talking to a manager. So in that case, the client won't own the messenger. But currently, we don't need to worry about the reporting things.
Okay.
I think it's fine. Actually, in my prototyping, I let the OSD own the Monk client instance, so it will work quite well with the one-to-one mapping model.
Cool.
And Redoc, is your change ready for review and we probably can merge it.
Well,
we can work on
the
it.
last thing I need to do is to use the new foreign message dispatch. I will do that. It will be ready till end of the week, I hope.
So it will be an interface abstracting the difference between sharded dispatcher and non-sharded dispatcher.
In the matter of the dispatcher, it's already defined.
Okay.
Let me point a commit abstract creation. No, guys, let me do that in the background.
hello? Anybody is speaking now?
Not me.
Okay, I can hear you. I just check if I can hear anybody.
So, Reader, what's this commit for?
1 second. Okay, got it. Terribly sorry for being laggy. Here is the interface for abstracting the dispatcher concept.
Yes.
Oh, I see.
Okay, so do you mean that you need to test it with foreign dispatcher and without foreign dispatcher and compare the performance?
Yes, that's one of the things we can do.
Oh, okay.
If we are preserving, if we would preserve the abstraction till the member testing, we could do that actually, and just see. I'm also thinking about I'm also thinking about doing the connection crossref even further. At the moment, if it's being used, it's still, well, let's say if your method is taking a connection ref. In the usage of it is like content. If we are switching, however, if we are switching to connection crossref, then you need to do something like that. The good thing, the absolutely good thing is that you are doing that explicitly. However, it also means that, well, we will need to have a lot of if-defs. So I'm thinking about sacrificing the explicitness and just creating some kind of connection crossref, but with overloaded operators. I know it can be even more. Well, it can be even more complicated. I know I'm sacrificing the explicitness, the simplicity. I'm not fine with that. Still, it would allow to have the abstraction.
I'm not quite follow. So
let me quickly prototype. It will be something like connection struct connection crossref inherits from Seastar LW shared PTR from foreign PTR from shared PTR from connection. Then inside with overloaded operator this and this, just to hide the difference between usage of connection ref and connection crossref. So even the connection crossref will be used the same. This would allow us to have basically fewer if-defs inside the code.
Fewer if else.
Yes.
Okay, so you mean if use connection arrow send directly, we don't submit to another core, but using the second approach, we add if branch to
like that,
submit
something like
core.
this.
So it is
If
explicit.
Star red, then connection abstracted ref is just connection ref. Otherwise, it will be the struct defined earlier. So that's the idea. But I have mixed feelings about it.
So in single-threaded OSD, it will be just a simple connection reference, and
Yes.
in non-single-threaded OSD, we can use xref, but the usage of the two connection reference are the same, right?
So could you repeat, please?
So so with this if def, we can use the same term with the same behaviors with or without this single-threaded OSD.
Yes, it would become abstract.
But I still not understand the difference between this one and this one. So
Well, maybe I will just pair apart.
okay.
Well, okay. Now I see. If we don't abstract the star difference, it means it will translate into having a lot more of the if-def blocks spread across our all code base. The abstraction of the ref would be just requiring just single if definition block. That's the main difference.
Okay, so
if I understand correctly, we will also apply the same if define technique to the dispatcher. So if I wanted to define OSD as a subclass of dispatcher, I probably will inherit from the foreign dispatcher if we go with if the with Seastar single thread is not defined. Otherwise, I will inherit from the plain dispatcher. Is that right?
Well, in the case of dispatcher, it might be more complex. There are differences in methods. Foreign dispatcher is adapter from the current dispatch interfaces, taking cross or not cross ref into connection foreign reference. Basically, reference wrapped with a foreign, with a dedicated name. Alright, guys, let me prepare.
But if we are going with we go with the one-to-one mapping, a plain dispatch will suffice, and we don't need to foreign dispatch.
Yes.
Foreign dispatch only applies to M2M mapping.
Yes, but the code we would write would need to be compatible also with the foreign dispatch interface. I mean, it would need to be aware about it.
Okay.
Okay. Reda, could you write some example to me where to use the first, and in which case we use the first method, and in which case we need to use the second? Just
Well,
some
just let me prepare a commit. I hope it will be ready
okay.
today or tomorrow's morning.
Okay, thank you.
But Reduk, if we want put our resource into the one-to-one mapping and to get the benchmark result, should we focus on the and only focus on the one-to-one mapping, and
Okay.
at the meantime ensure the interface are compatible with the M2M mapping instead of implementing them?
Okay, that's a bit different story.
Yes, because I think we
I'm just worried a bit.
actually we have a lot of assumption in here, and it's a little bit complicated, and because on one hand we are preparing for one-to-one mapping, one to M2M mapping, and on the other hand we are trying to have a lot of assumption in our code that we believe that one-to-one mapping is the simplest and probably is more performant.
Likely.
And yes,
Kifo, let me be
on the
honest,
other hand,
I
we
started
are trying to be
working.
more flexible.
I started working on abstraction last week. Was a bit less certain about the one-to-one mapping. The more time I spent thinking about it, the more reasonable it appears to me.
So you think it's more reasonable to have the abstraction, right? Or
Well,
just
I
focus
thought
on the
that
one mapping at the
last
time?
week. I thought that now I'm not so entirely sure. It's about the matter of flexibility we want to preserve.
You're not entirely sure about what? About the abstraction approach?
About the continuation of the abstraction concept.
Okay.
Maybe just treating the whole phase of read over memstore testing, just even pre-prototype, is a better way. I'm not sure.
Yes, I think we need to define the scope explicitly and to limit the scope explicitly instead of put our limited resource to a full-blown
Yes.
target.
By
Because
the way,
we have already discussed this and have a sort of a concept on one-to-one mapping, at least for short term, to get a number to ensure that we are on the or to verify that our idea is right or wrong. In the worst case, we should abandon the ship. And the best case, we know that it's performs very good, and we should go this way.
Yeah, that sounds reasonable. By the way, I in the discussion on the self-devel, there is also a lot of that we basically haven't defined the scope for the whole project, and people are mixed some different problems.
Yes.
I personally think about the Crimson OSD just like a project, small project to consume very fast devices. But I started to think people are also thinking about bringing much more devices, much more disks, much more storage to the whole project.
Sorry, I don't follow you. I think Chrome also should also work. It's focused on the performance on fast device, like for example the NVMe device, but it should also work well on slow device like HDD.
Yes, it's different. I mean that for me personally, Crimson is focused on consuming, all on consuming a device, slow or fast, in very performant way.
Mhm.
But I also observe that some folks are thinking about bigger scope. That Crimson, it's not only about single device, about efficient device consumption, also about bringing more capacity to the whole TEF project. Capacity for more cores, more devices, more storage. Okay, anyway, let me write to TEF-Devel. I will try to explain.
Okay, cool. But I think these two problems are also no go.
Exactly, and trying to address them in the same project might hide some better alternatives.
But I think Crimson OSD can address both these two problems to adapting fast devices and to make a better use of multiple core CPU, but make bet to eliminate the cross core communication and the low
Sure,
contentions.
I was thinking
That's
about. Let me provide an example.
Seastar OSD does.
Mike is thinking about very beefy, very wide OSD. It has some nice benefit of reducing the number of OSD instances you would need to deploy on a given set of storage capacity. It means it also that way we would also minimize the pressure on our RAIDOS infrastructure, on the OSD map size, etc., etc. But basically,
Okay,
I think it's a different problem. We are mixing. It's a very fundamental one. Whether we have actually the crash capacity, the crash capacity, whether we have the RAIDOS capacity, but I believe they are orthogonal to the crimson OSD. The sole junction point between efficient efficient device consumption and radius capacity is that some solutions of the Crimson project are playing with the number of OSD instances we could finally have. But they are different problems. Let me write to TFDevel.
The goal is not to push the management or more smart, make it smarter, but make it quicker and be able to let multiple OSD work side by side in a more peaceful way instead of
exactly. I would
competing
love
with each other.
Well, I have no doubt that in general, the class deployment will need to be more smart. But I would love to have this smart test, not in Ceph OSD, but rather in Rook, Ansible, whatever we do to have to encapsulate our deployment logic. It's just cheaper.
Yes, I agree with you. Okay, so the idea is that we need to focus on the one-to-one mapping, but be aware that we could switch over to M2N, but we don't need to put a lot of resource on the adapting to. Say it again. Sorry.
No, I think we don't need to consider M2M now. Just focus on the one-to-one.
Not to consider it a little bit, even for compatibility with M2N.
For M2M, you have to add more complexity code to make it fix to M2, adapt to M2M mapping. But you need to consider it now. We can extend the code later.
It's reluctant to admit that, yes, but yes. Because I realize that Zredo has put a lot of efforts on the abstraction layer. It's a shame to abandon it.
Well, I wouldn't be locked by that.
Okay. And Yingxin, how's it going? I believe you are fixing a nasty bug in Messenger.
Yeah. So last week, I majorly trying to the two of the fixings are merged in the Ceph, and this one of the Seastar framework bug is also merged in the Seastar framework. So maybe we can update our Seastar repo to
Okay.
This
is this the one the fix you are posting, the PR you are posting against the shift/Seastar that I was reviewing?
They think it is not it only fixes the POSIX stack issue, and it's not generic fix, so they picked up another way. This one.
Okay, so we just need to pick up, and the fix has been merged into upstream, and we just need to pick up it and update our sub module.
Yes.
Okay. I'll check it out and do it as it.
Yeah, this commit is here. I just paste it. And yeah, I'm still working on that bug. Hope I can fix this week.
Congratulations! So this is the first contribution to the Seastar.
Thank you.
Okay, so you are still using the two ways.
Mhm. But I have another question. So if we are focusing on the one-threaded OSD, do we still need to implement the sharded messenger?
I don't think so.
Sharded chromosome. So we can stop that effort and move forward.
Yes.
Yeah, but I still think the bug I'm referring to is still with one-threaded messenger, because our unit test, our all connections in the unit test are living in the same shard, and they still have some issues. And I pasted in the patch, the sharded messenger patch, about the error, the specific error I have. That
I
issue.
don't follow. So the issue also applies to the single threaded messenger. Is that true?
I think so, because all the connections are sharded by peer IP, and they all have the same IP. So all the connections in the sharded messenger unit tests are actually running in the same core, and they still have this issue. That's why I think it is related to the one-threaded OSD and the messenger.
Makes sense. But in that test, we do move the established connection, right?
Yeah, but
we don't.
But it seems not from that issue, because it is in the middle of the read in the write operations. It just failed randomly, and some writes are successful, and most of writes are successful, but some will raise the segment fault as if the packet is already destructed, but still trying to be scheduled in the continuation.
I'm wondering if it's related to the life cycle management of a package, because a package is its own is the underlying temporary buffer is the life cycle of the underlying buffer is managed by the deleter.
Yeah, so I think it may be related to
and
this.
The deleter is pointed to the underlying package. A packet, sorry.
Yeah, packet.
And the package is created by the core where it is received.
Yeah, the write sum function in underneath the Seastar framework are trying to read some content from the packet, but it will cause segment fault. It means that this packet may be already destructed.
Yeah. My concern is that it's also related to multiple communication. Probably not.
Yes,
anyway.
yes.
So we overdue. I think the gist of our discussion is that we will be focusing on the one-to-one mapping and only on it. If the goal conflict with the M2N compatibility, we should consider the performance of our productivity, performance of a developer, instead of compatibility with the M2M model. And I think we will be focusing on the bug in Messenger and Chunmeng, I'm not sure what your next step is.
So I think think the POSIX object store will be stopped here, right? If we need it, we can start later. You can send me
Yes.
another work currently. I can help you to
Rita, what do you
work on
think? I think the missing, the next thing I can foresee is that to connect the handle methods with
Yes.
with
See if
the featurized or non-featurized memory store.
yep. I see a couple of possible items. We need to have the futurized object store. We also need to we also need to bring the futurized mem store, and finally glue the manager. Glue the messenger the dispatch logic to object store. Basically, it's the read IO path.
Okay.
No, what you mean the futurized object store? Futurized memory store.
Futurized object store is just the interface. The futurized mem store would inherit from, publicly inherit from. It will implement basically. But the futurized mems will basically use multiple inheritance. It will privately inherit from current mem store just to claim for the current implementation we have. And secondary, it would also it would publicly inherit, I mean implement the futurized object store.
I still don't understand what the futurized. It is no block, so we needn't return the Seastar future.
We don't need, but we might want to. Well, basically, maybe even that's the question, whether we want to have the abstraction at the moment, a very simple one for the object store design.
Yeah, I think it's more related to the how we foresee the future of the
Yes.
interface of
it's about interface,
the
not
object store for
implementation.
Yes, even it will return the stuff we read from the memory. We pretend it will take some time, and it's async. Even it's the synchronized read.
Yes.
No, I don't think it's reasonable, because when you think it asynchronous, it is a return the Seastar future, and then they will put to the schedule, Seastar schedule. It will waste time. If it is not blocked, just use the general code, not use async mode.
No, I don't think so. It will be put on the task queue in reactor. If the memory, if the return variable is returned by
make ready
future, it will be read right away instead of put on the task queue.
Yeah, but it's not blocked. It's why we need to return the future.
Just to stress, we have a design, at least very beginning.
Yeah, it's server as a document actually, to tell the reader or the future developer that this method is supposed to be async, but currently we are focusing on the memory store. That's why we return it using the make ready future.
So why you just return make ready future? Add wrapper and then call the store read and make.
It's more about politics than about the implementation. It's more about politics than about engineering, basically.
Yes, you can consider it like comments or something. But we materialized it using Seastar future. But if you feel better about this, we can.
Are you sure you
we
just
can
want to
we
return
can
make
read
ready
it.
future?
Yes,
Well,
I'm sure. You can just read the future,
yeah,
the implementation of future. If
Yeah,
it's a ready
you
future, it
can
will
you
be written right
can
away.
yeah, you can return make ready future. It will execute immediately continuously, but it's not used here. It's not. You can just call the style API. It
exactly.
will
For
execute
this
it.
particular appliance, you can. I'm thinking more about the future, about having arguments in the future
Don't
about
consider
how
a future. We just do
about,
the POC.
yes, but if the POC is successful, there a new discussion, completely new discussion will pop up. It will be about how to come. It will be about object store. Whether we want to go with the adapter design, whether we want to consume Blue Store, maybe maybe make a completely new object store implementation. Who knows?
Yes, it will serve as a reference design and a guideline for the future design.
Don't consider Blue Star
And
now, just the memory star.
if we want to switch over
It's
to
cheap.
your alien future as the store, that will be easier if we follow this design.
I still don't understand what. Alien object
Okay.
style, you
Anyway,
said stop here, stop there. Just write to me what I'm doing.
it's not a big deal, but
It changed several times. It always changed.
okay. If you feel better using the futurized interface, I think we can do it with existing, just called the memory store. But we need to be aware that it will be futurized in future if our project it will be successful, and I really want to believe it will be successful.
Yeah, if you want to use the POSIX thread, it will be futurized. But if you don't want to do POSIX thread, it needn't use the futurized. It's not blocked. If it is not blocked, we can just call the general synchronized code is okay. No need into the.
Today, I expect in the future we will have close future. We might get 3 different implementations of the future object store interface. Possibly one is the adapter concept from futurized object store to object store using a thread pool. Second one is just for testing. It's the futurized mem store, possibly.
Just go to the first
but
POC, right? One-to-one
Yes.
mapping.
But it
Not
might be all
talk about the
just
future.
after the POC. There might be. I expect a huge discussion will pop up, and it might turn into a third implementation of a futurized object store. So if we have the catch of a new interface, it could be useful at this step.
Yes,
I
I
won't
really
be
want to
surprised.
reuse what we have for the future
Yes,
development.
yes, it's maybe even other. I think it would be just approved. We just started thinking earlier about the design.
I just want to focus on the POC memory style one-to-one mapping. Told me what I do know.
Okay, I will make the commit.
Okay.
Let's focus on the POC.
Yes.
Yes, that's I think that's the gist of the discussion, and I agree with you. It's it would if it involves less effort, let's go with it. Let's go for it.
So, Kafu, can you write to me and describe for the POC what I need to do?
Sure. I will send a mail to the Safe Devil to define the scope of a current Chromosome OSD project, to refine it. If I'm not if if I have any oh, sorry, I muted. I will send a mail to SafeDevil and to define the scope of the Chromosome OSD project at the current status for the next 1 or 2 months before the hopefully before the developcom, and you guys could correct me if there is any misunderstanding.
Okay.
And by the way, the CFP of deadline of CFP of developcom will be February the 1st. I will also send you guys a proposal so we can at least we can the borderline of it is that we will could co-present the talk, or if we have no more stuff to talk, we can have 1 or 2 of them. Is it cool? Okay, if there's nothing else, let's call it a day.
Cool.
Okay. Then the guys, nice evening, Tremay, and have a good afternoon, guys.
Thanks.
And,
Same
yeah.
for you. See you. Bye.
Bye.